Yes, student. Now to apply the given assumptions of valence bond theory, I am dealing one of the question. What will be the hybridization state, geometry, and magnetic property of tetrachlorido nickelate because it is two anionic complex, so nickelate and what ion, okay, and its oxidation state should also be there. Its oxidation state we will find and then we will write its oxidation state. Student, very first what we have to do, write the symbol of given element. This is nickel. Write its atomic number. You know, it is what, 28. The configuration is, this is for argon, okay, and the argon becomes electron how many? 18 electrons. Now remaining 10 electrons are there. So how to fill 10 electrons? Very first, the 2 electrons are filled in 4s orbital, that is 4s2. So 18th, 19th, and this is what, 20th. Now remaining what, 8 electrons. These 8 electrons will be enter in d orbitals. And which d orbitals? 3d orbitals. So this is 3d and what, 8. Now according to Hund's rule, this is 21st, 22nd, 23rd, 24th, 25th. This one is 26th, 27th, and 28th number of electrons. Now it is filled. Now student, what to do? Write its oxidation state. So how to find oxidation state? It is very simple. You start writing the oxidation number of each known species common state. So you can write Ni. This is what? Consider it X plus. Now the ligands are 4 and it is of Cl. So Cl has charge what? -1. So 4 into -1 is equal to, now overall complex is -2 charge, therefore -2. So now when you will solve it, it will give x minus 4 is equal to -2, or you can write it x minus 2 is equal to 0, or you can write it x is equal to 2. That was what? Here the nickelate ion present in 2 oxidation state. So now you have to write the electronic configuration of nickel 2 cation. Now its atomic number is 28, but number of electron will remain what? 26. This number of electron. So the configuration will be as earlier. Argon, it is written what? 18. Now the 2 electrons are removed. So the 2 electrons will be removed from s orbital. Therefore there will be no electron in s orbital. So remaining all the electrons will be present in d orbitals. Okay, like this one and this one and this one. But student, being it belongs to 4s, okay, this is what, 3d and 4s, that means what, there is 4p orbitals are also present over there, but all these 4p orbitals are what? Completely vacant. Now what? To hold 4Cl, okay, lone pairs ligands, lone pairs electron, okay, nickel plus 2 must avail 4 vacant orbitals of equal energy. So 4, okay, vacant orbitals will hybridize, okay, as Cl is weak ligand filled, ligand, so is unable to pair up unpaired orbitals. Okay, so 4s plus 4p, 3 orbitals will hybridize. Okay, That means what? Cl is unable to pair up. That means what? There is no chances of hybridization of d orbitals, because in the hybridization, in the case of coordination compound, only vacant orbitals participates. Unpaired orbital or completely paired orbital do not participate. That means what? That means now the hybridization will takes place. Here the hybridization will takes place. After hybridization, equal energy and strength having 4 vacant orbital will be there. Okay, now being the 1s and 3p participate, therefore the type of hybridization become what? sp3, and the geometry is become what? Tetrahedral. So in this way we can get the answer. Now there will be 4 Cl ligands. Each Cl ligand will donate what? Lone pair electron. This will be gained by the Ni2 cation. So now the complex is getting formed. Getting in this complex. Now nature is there are 2 unpaired orbitals in where n minus 1 d orbitals, hence the complex is paramagnetic in nature. Complex is paramagnetic in nature. I told you earlier, the magnetic property depends on number of unpaired orbital. So student, the most important thing which you all have to concentrate, what? Very first you have to learn atomic number, then you have to learn how to find the oxidation state. Okay, then writing the electronic configuration by applying the Aufbau, Hund's and Pauli's principles. Okay, it is of 11th class knowledge. Then what? The type of ligand, which type of ligand is getting approached? It is of weak field ligand or it is of strong field ligand. Okay, and in this case how they can pair up or unpair the orbital. Then the next one is the hybridization. Here the specific hybridization takes place. That is what? Only vacant orbitals involved, unpaired orbital do not involved. In 11th class Valence bond theory we have seen that unpaired orbitals involved, but here vacant orbitals are getting involved. It is because the lone pair can be gained only by vacant orbital.